Hey everyone, I got a couple questions about how to complete some of the quiz questions in our lesson 3, conservation of momentum. So I'm just going to go through questions 2 and question 7, just give you guys an idea of what to do with these. All right. So before even reading the question, we just want to kind of identify what is the formula that we're going to use throughout this lesson. Our formula is all about finding the momentum of our objects before collision and after collision. Now, if we know the total momentum before collision, whatever number we get there, we know that that is going to be the total momentum after collision. Now, typically, when you have two objects that are colliding together, their masses are not going to change, right? So our masses on both sides of an equation are probably just going to stay the same. So the main things that are going to change in the equation are the velocities, right? You bounce two pool balls off each other, right? Their masses don't change, but their velocities will change, right? From before they collide to after they collide. So what we want to do is we want to apply this formula to this example problem above. All right, in this particular case, we have a railroad car whose mass is 30,000 kilograms. It has a velocity of 2.2, collides with a second railroad car that also has a mass of 30,000 and is currently at rest. All right, the question's asking what is the velocity of the two cars afterwards? Keeping in mind that these two cars stick together after a collision. That's going to be kind of a key point that we want to keep in mind. All right, so our first step always is write out our formula we're going to use. We've already done so. Next is let's plug in the numbers we already know. All right, so we know the mass of our first object is 30,000 and the velocity is 2.2. We're going to add this to the mass of our second object, which is also an identical 30,000, multiplied by its velocity. Its velocity is at rest, so it's 0. Makes that easy. As we mentioned before, we know that the mass of our objects don't change, right? So mass of object 1 is 30,000, velocity we don't know, plus mass of our second object, which again does not change, velocity we don't know. So here, let's go ahead and let's solve some of the things that we can figure out. So let's do this first left side of the equation, 30,000 times 2.2. That's just going to give us 66,000 plus 30,000 times 0, which is just 0, right? And this is going to be equals 30,000 velocity 1 plus 30,000 velocity 2. Now, a key thing here that we find out in this problem is that the two cars stick together. So this is kind of a key piece of information. So instead of having two separate objects, we just have one object, and they're going to move with one velocity if they're sticking together. So what we're going to do here is this allows us to actually combine these two masses, right? Since instead of two separate cars, they just get lumped up into one. So 30,000 plus 30,000 is 60,000. And then since they're combined, they're going to be moving with the same velocity. So instead of V1 and V2, we just get V. Now, we just want to solve for V, right? We got 66,000 on one side, 60,000 on the other. We're just going to go ahead and do some simple algebra. I'm so sorry. This should be 60,000. All right, so that gives us equals V, 66,000 divided by 6,000 is going to be 1.1. So our final answer is 1.1 meters per second, since that is the unit for velocity. Okay, so ends up being this answer. All right, for question 7, I actually have this in here by mistake, but it does kind of show you some of my steps. So I'll just kind of leave that open. All right, once again, let's write out our formula, right? Before we even go into any of this problem, we know that we have the law of conservation of momentum. So before our collision, we have mass 1 times mass 1 times velocity 1 plus mass 2 times velocity 2 equals mass 1 times velocity 1 plus mass 2 velocity 2. And this is all after. All right. Knowing this formula, let's go ahead and plug in numbers we know. So in here, we have a 0.05 kilogram bullet. Okay, so that's going to be the mass of our first object. Strikes a 5 kilogram wooden block. Okay, so our mass is 5. And embeds itself in the block. The block flies off the stand at 9 meters per second. What was the original velocity of the bullet? All right, so a couple things that we can kind of figure out here is 1, the original velocity of the block was 0. We don't know the velocity of the bullet initially. We know that these two objects are moving together, so kind of like our train example. So our mass is going to be the mass of the bullet plus the block. So our mass is going to be 5.05. And it has a velocity of 9 meters per second. Again, we know that because the block and bullet are moving together as one object. All right, so again, let's go ahead and simplify this. We get 0.05 times velocity plus 5 times 0 is 0 equals, we got 5.05 times 9, which gives us 45.45. All right, and then we just got to solve for b. Just some basic algebra again. So I'm going to do some division. Figure out what's 45.45 divided by 0.05. Should I do this right? 0.05. That's going to equal. So our velocity equals 909 meters per second. And again, we want to just kind of combine our common sense with the numbers that we get. So in this case, a bullet flying before it hits anything, before a collision, has a velocity of 909 meters per second. So that's almost a kilometer a second. And obviously we know bullets fly pretty fast, so that number actually checks out. And luckily that's one of our options here. All right, kind of figure that out, then you are good. All right, and that is how to do problems 2 and 7. If you guys have any other questions, feel free to let me know.